everyone, welcome to my channel. Are you excited to learn about acids, bases and salts? I want to show you that acids, bases and salts are not just limited to your chemistry textbooks or chemistry labs, but also they are present in your everyday lives. So here I have some simple everyday things and I want you to be a science detective and tell me whether they contain an acid, base or a salt. Now that we have looked at some examples of acids, bases and salts, let us take a look at the properties of each and how they differ from each other. So let's build a table of differences together. 6 important things we will look at are examples, taste, neutralization, identification, solubility in water and indicator test. So let's start by filling in some examples. When you think of acids, bases and salts, you can keep these simple examples in your mind. Let's look at taste. What is the taste of acid? That's right, they have a sour taste. For example, orange and lemon are sour because of the citric acid they contain. Bases have a bitter taste, and that's easy to remember. B for bases and B for bitter. Salts, as expected, have a salty taste. But there are some salts which have a sweet, sour or even a bitter taste. Let's fill in the taste for acids, bases and salts. Let's look at neutralization. Neutralization means to cancel the effect of. An acid can neutralize a base, and of course a base can neutralize an acid. Now, what is the famous neutralization reaction in chemistry? That's right, acid plus base gives us salt plus water. Of course, an orange plus soap won't give you salt and water. So what is the acid and base that's needed to produce salt and water? Exactly, it's hydrochloric acid and sodium hydroxide, which will give us salt and water. And this is an example of neutralization reaction. Let's fill in the table for the neutralization row. Now let's look at identification. If you are looking at a new compound and you know the chemical formula, how can you identify if it is an acid, base or a salt? All acids contain hydrogen. For example, hydrochloric acid is HCl and sulfuric acid is H2SO4. So all the acids have hydrogen in them and bases contain hydroxide ions. In salts, the simple rule to identify a salt is that it should contain at least one positive ion other than H plus and one negative ion other than OH minus. Now let's take the example of sodium chloride. So it contains the sodium Na plus and chloride Cl minus ions. Let's pin the important identification points on our concept board. These rules help guide our decision to find acid, bases and salts. Next, let's look at solubility of these compounds in water. All acids are soluble in water. Unlike acids, most of the bases are insoluble in water. The bases that are soluble in water are called alkalis. And coming to salts, salts are of two types, soluble in water and insoluble in water. Let's place the solubility details for acids, bases and salts. Now let's look at indicator tests. Here I have three famous indicators: litmus paper, phenolphthalein, and methyl orange. For an acid, blue litmus turns red, and for a base, red litmus turns blue. And here I have a few more examples for your better understanding.